Okay, we're looking at Dijkstra's algorithm, and as you know, Dijkstra's algorithm finds the shortest path from a start node to every single other node in the graph. And here we have a graph. It's a weighted graph, and it's from a real A-level OCR question exam paper. And the question is to find the shortest path from A to J. But remember, Dijkstra works out the shortest path for all nodes anyway. Okay, so the first thing we do is to lay out our table. So we want columns for the node and also a check on if we visited each node neighbor. And that's a question. And the next column will be the distance from start node. In this case, it's going to be A. And our last column will be the previous node. Okay. So all will become clear as we go. Right. Now the first thing you do is we want to fill in the nodes that we have in the graph. And so we go from A to J. So let's put them in. Okay, and the next thing we're going to do is fill in the rest of the table that we can. Now, have we visited each node neighbor? For A, no, and we haven't done it for any of them, so we need a no in each of those rows. Now, do we know the start node from, do we know the distance from the start node? Well, we do for A because it's 0. Now, we don't know the distance yet from the other nodes, but we're going to set it to a special value, infinity, and we'll see why. We just want a large value that we can say when we do work out what the distance is from a node to the start, we can say, is that value smaller than our current value? And that's why we set this value to start with to be very, very high. And we can't fill in the previous node. Well, maybe 3, so it's nothing. Okay, so now the next thing I do is make an additional table. Okay, the node and the node neighbors. Okay, now we'll be filling this as we go. Now, as you can see, I also am introducing the idea of a coin to keep track of where you are in the algorithm. One of the problems of this algorithm is losing track of where you are. That's what I've noticed people have problems with. Okay, so we're going to use this coin. Now, where do we start with? So we're looking for no in this column and also the smallest value here. So there's only one option for that because we have no and a 0. So we put so this is the node we're starting with. So we put our coin at A, and then we are going to look at node A. And what are the node neighbors of A? It's just B. Okay, so now we're going to process the neighbors of A. Oh, and we also want to put this other thing in, little annotation to say update both. And the reason I put that there is that I notice also when people fill this table in, one problem is forgetting if you update this column, you need to update this one. So why not put it in on the table anyway? There's no problem with doing that. Okay, so right, back to where we are. Okay, we're processing all the node neighbors of B, all the node neighbors of A, and that node the neighbor is B. So we need to go to the B row, and we're looking at the distance to the start. So it's going to be 5 plus the distance from A to the start. A to A, well, that's always going to be 0. Now, I know this looks overkill, but you'll see why. We're going to follow the same process all the time. So that's essentially why we're putting the 0 here. So 5 plus 0 is 0. 5 plus 5. 5 plus 0 is 5. And that is smaller than infinity, so we're going to cross that out. Now, we have to remember to update this column. And our previous node was A. Same here. Okay, so now we've done A. We've looked at we've visited all the neighbors of node A, so we'll put a Y here. Okay. Right, now, and we've finished that one. Okay, so now we want to repeat what we did before. We're looking for an O in this column and the smallest distance here. So that's going to be B. Okay. So we put our B here. Now we want, and we move our coin over here to help us remember where we are. Just a marker. Right, so our neighbours of B are A, C, D, and E. Now, we're going to process our neighbours. Now, if we have a node we're looking at, our neighbour, where we have a Y there already, we don't need to do anything for it. We just cross it off. Okay. Right, now we're looking at C. Okay, C to B, well, that's 8. And we're looking at C, so we go to the row C. So that's going to be 8 plus, and what's the distance from B to the start? Where we can nick that from the B row. Okay, that's 5. Okay, so that's 13. 13 is smaller than infinity, so we need to keep that. So we're going to cross that out, and then we need to remember to update both. And our previous node was B. Okay, so now we've finished that one, and we are still processing node B, and now we need to look at D. So we're just repeating the same process. Okay, so D, whatever value we come up here is going to be smaller than the infinity, so we know that we're going to do an update. So 9 plus the distance from B to the start is going to be 5. That's 14. So that is 14 is smaller than infinity, so we can update that. And then the previous node is B. And we can cross it off here. Okay. Now we're looking at E. So that is going to, and again, we're going to definitely update the value here because any value is going to be smaller than infinity. That's going to be 3 plus the distance of B to the start, which is 5, and that's 8. And we have to remember to update both. That's going to be the B. Okay. Right, now we have processed all the neighbours of B, so we have finished looking at node B. Okay, now which node do we look at next? Again, this is the third time we're doing it. We need to know in this column and the smallest value here. Okay, so that's going to be the node E. Okay, so we put that E here, and we move our little marker over here. Helps us remember where we are. In fact, using this method, you can go away and come back and remember where you are, which I think is a good test of the notation and the coin trick. Okay, so what are our neighbours of E? Okay, so that's a B and an I. Okay, right, so now to process the neighbour B, we need to go to the B row, but we've seen that there's a Y here, so we don't even need to do anything. It's good news, so we just put a line through it, don't need to do anything. Okay, now we're looking at I. There's no Y here, so we do need to do something. Now, there's an infinity here, so we know that whatever path we come up with, it's going to be less than that, so we will have an update. Now, so I through, and we have to go through the node, so that's going to be 4 plus the distance of E, which is 8, and that gives us 12, and we have to remember to, and that's less than infinity, so we can update, and then we have to remember to update the previous node, and that's going to be E. Right, and we've finished I, and now we can put a Y because we've finished node E. Right, okay, so now we're doing the same thing we did before. We need to know in this column and the smallest value here, and that is going to be a 12 for the I. So put the I here, and move our coin here to remind us where we are. Now we need all the neighbours of I, which is E, F, G, and J. E, F, E, F, G, and J. Okay, these are all the neighbours of I. Now, E. We're going to process E. Now, E has already been looked at, and there's a Y there, so we can cross it off. F has not been, so we have to enter that. And whatever value we come up with, it will be smaller than infinity, so we're going to update for sure. And F, so that's going to be 3 plus the value of I to get back. The distance of I to the start, which we can read off here, is 12. And that's 15. Now we updated this, so we need to update the previous node, and the previous node is I. Okay, so we've finished F. Okay, and now we're doing G. So if we look at G, again, we're going to definitely fill this value, update this value, because whatever value we have will be smaller than infinity. So G is going to be 6 plus the I, which is 12, and that is 18. We always have to update both, and then that is I. And 18 is smaller than infinity, so we can update that. Okay, we've finished G. Now we're just got J to go. Now, again, whatever value we have is going to be smaller than infinity, so we know we're definitely going to update. And so that would be a 2 plus distance from I to the start, which is 12, and that's 14. And then that's smaller than infinity, so this is our new value. And then we update both columns, and then that is going to be I. We finished it. Okay, now again we go back and say which is our next node we are going to look at. So no in this column and the smallest value. So 13 there, and we have a 12. Oh, actually I forgot, because we have already processed that. we put a y here. Okay, so that 12 is already gone, so we finished that. So we got a 13 for C, so that's the smallest, so we put that C there. And we can move our coin over to C. What are our neighbours of C? Well, just B and G. Okay, so B. Have we processed all the neighbours before? Have we got Y in that column? Yes, so we don't have to worry about that. And G. Okay, now for G, will our value be smaller than 18? If so, we update it. So that will be a 2 plus the value plus the distance from C to the start. And that'll be 2 plus the 13. So 2 plus 13 is 15. That is smaller, so we can cross that off. And then, because we updated this column, we need to update both. And the I will become C. Right, so we have done the G. And now we have finished looking at all the neighbours of C, so we put a Y there. Okay, what's our next node that we'll look at? Okay, we want to know in this column and the smallest value here, 14, 15, 15. So we've got two 14s, so no matter we can go, we'll just take the first one, D, and we move our coin over to D, and our neighbours of D are B and F. Now we're going to process these neighbours. Okay, so B, we've got a Y here, so we don't need to do anything. Put a line through it. That's good news. And then the F. Okay, there's no line. It's still a no, so we could update it if our path is smaller. So for F, it's going to be 2 plus D, the distance of D to the start, and that's 14. Now, 2 plus 14 is 16, which is not smaller than the 15. So this will not update. So we're not going to update it. And we have finished F. Okay. Right, so, and we have finished D. All the neighbours of D? Yes, we have finished all the neighbours of D. Okay, now, which is the node? Yeah, you guessed it. Which is the next node? We have to look for an N in this column and the smallest value here, and that's the other 14 we had. So this is a J. And we put our coin, I'll remember where we are, over at J. And what are the neighbours of J? Well, we have an I and a H. I and H. Okay, now we process the I and then the H. Now, has I been processed fully before? Yes, so we don't need to do anything, so we just put a line through that. H, we haven't got a Y, so we need to do something. In fact, we know that we definitely will update, because whatever path we have, it will be smaller than infinity. So H is going to be 4, because we have to go through at the node that we're looking at. 4 plus, and then the distance of J to the start is going to be 14. Okay, 4 plus the distance of J to the start, and we can read that off this row here, that's 14. And that's going to be 18. Now, remember we have updated this column, so now we have to update this column, and our previous node is J, so that goes in there. Right, now we finished J, all the neighbours of J, so we can put a Y in there. Okay. Right, now what's our next node we're looking at? The smallest value with the N and value here. So we have two 15s here, so we can just pick the first one that's going to be F. And the neighbours, and we move our coin over to F, and the neighbours of F are D and I. And for D, we have a Y here already, so we don't need to do anything for that. For I, we have a Y as already, so we don't need to do anything for that. Rubbed out the wrong one. Now, I'll do that again. Because we have, we're processing I, and because we have a Y here, we don't need to do anything for that. Oh, we did that already. And now we're back to saying that we have finished all the neighbours of F, and we're saying which node do we look at next. We're going to need a no in this column and the smallest value. There's a 15 there for G, so we need to do that. Okay, so G, and we move our coin over to G, and there's 3 neighbours, so C, H, I, and C. C has a Y, we've already looked at that, so we can just skip that. H, we haven't got a Y here, so we need to potentially update this. Now, H, right, so 3 plus the distance of G from the start, so it'd be 3 plus 15, which is 18. 18 is not smaller than 18, so we don't update the row with the smaller value. Okay. All right, so we've finished H. I has a Y here, so we don't do anything further, so we just cross it off. Now, we've finished looking at all the neighbours of G. Okay, now there's only one that we've got left, and that is H. And we can move our coin over to H. What are the neighbours of H, G, and J? Right, so let's look at the G. Let's process the G first. It's already got a Y in it, so we don't need to do anything. Let's look at J. It's also got a Y in it, so we don't need to do anything for that either. Now, we have finished. Right, actually, because we've processed the neighbours of H, we can update this. Now, we have looked at all the neighbours of every node, and we have therefore finished Dijkstra's algorithm, and we can go back to answering the question. Now, so what's the shortest path of this from the start node A to J? Now, so what you do is you list out in reverse from J to A first, and you do it like this. So it'd be J, and then the previous node is I, and then we go to I, and then the previous node would be E. We go to E, and then the previous node would be B. And we go to B, and then the previous node would be A. And that's our route from J to A. But we need it. Let's get the path in the correct order. So let's just reverse this. So that would be A, B, E, I, and J. And then the cost of that path, the shortest path, will be here, 14. Okay. So let's look at what that path would be. It'd be A to B to E to I to J, and then that would be 8 plus the 4 is 12 plus the 2 is 14. So that looks right. Okay, now, so we've answered the question. There's the path and there's the cost. But just to show you, let's say what's the shortest distance of I 8i, well, we'd look that up here. It's going to be 12. Okay? So hopefully you'll find this method easier to perform. And just remind you of the changes that I've included. Use a coin to indicate where you are in which node you're looking at. Use this table to list all of the node neighbours of the node that you're looking at. Always lay it out in the same way, no matter what the question is. For Dijkstra, whatever the graph is, always lay it out in this way, and don't forget to put this reminder when you update this column. You also need to update the previous node. Okay, hope you found that helpful.